Hi, today we're going to have our second lesson on experiments and causation, and we're going to try and give you some tips and some vocabulary associated with designing good experiments. We're going to begin with a little example problem, and then we'll use that to get into vocabulary a little bit. On Super Bowl afternoon, you've decided to compare the number of kernels left unpopped by a generic and a brand name popcorn and by your hot air popper and your oil popper. You have time to pop 20 batches of popcorn before the big game. Folks, that's a lot of popcorn for sure. But if you think about this, two things that you think will influence or impact the number of unpopped kernels. Here comes some vocabulary. The number of unpopped kernels, folks, that is called the response variable in this experiment, because that's what you're trying to make a change to. Response variable. You have two things. The proper name for those are factors. Two things that you think will influence the number of unpopped kernels, and those factors are the type of popcorn, and you have two of those, generic versus name brand, and the type of popper. And you also have two of those. You have hot air and oil. That means that if you think about that, we should have 4 different combinations that can come out of that. You'd have generic with oil, generic with air, you'd have name brand with oil, and name brand with air. Well, that's 4 different arrangements, if you will, of popping things. Those arrangements are called treatments. The factors are the things that you think will affect your outcome. The factors are the things that you think will affect your outcome. Levels of those factors, we have 2 each for popcorn and popper. The levels are differences within the factor. Treatments are combinations of the levels, if you will, the factors and levels. So we have 4 different treatments that we want to apply to our popcorn. Now you got to think about this is the cerebral stuff about our experiments. Now we got to get down to the nuts and bolts. We have 20 time periods that we can spend. It says time to pop 20 batches, so really we have 20 time periods. And if you divide that by the number of arrangements or treatments, you'll see that we are going to be able to do 5 batches with each treatment or arrangement. Okay? That's important, folks. Really, 3 things that have to be in every good experiment, and we've just touched on the first one here, replication. You don't want to just do 1 batch of each and say, voila, I found the answer. You want to verify by doing multiple times. So replication is an important part in any experiment. So 5 batches with each arrangement. Another important factor in any experiment is randomness, and you need to randomize in an experiment so that you can minimize confounding. Okay, so we are going to randomly assign to each time period one of our treatments. So if you think about that whole idea of randomness, we don't know. Like, we don't know. Maybe the hot air popcorn popper does better after it's been on for a while. You know, maybe it takes it some time to heat up. So if we happened to put all of our hot air stuff at the end, we made our last batches all be hot air, we might get a different result than if we mixed up the hot air and the oil in our time periods. It might be that the hot oil, or that your oil popper starts scorching after it's been on for a few minutes. So when you do that random assignment, what you're trying to do is make it so that differences in the response variable, so the number of unpopped kernels, are based either on chance or on your factor, the thing that you thought would make the difference. You're trying to minimize confounding so that you'll be able to tell what really made the difference. Was it the popcorn popper? Was it the popcorn? Was it some combination of both? Randomness helps you do that. Every experiment needs to have replication and randomness. So we've got our experiment set up. We're going to randomly assign to each of our 20 time periods one of our 4 treatments, right? And at the end of all this, we want to look at how many unpopped kernels there were from each batch and from each type of batch, if you will. So we want to count the number of unpopped kernels, from each batch, but we also want to find the average or the mean of unpopped kernels from each treatment. And then we get to the guts. This is the final step. Compare, right? Every experiment, I mean, that's the idea. Compare results. See which one was better. The 3 big things about experiment is they all have to have replication. Got to do it a lot. Randomness to limit confounding, and comparison. There would have been no need to do an experiment if you didn't want to compare the results. You were looking to see which would do better. So replication, randomness, comparison belong in every experiment. Let's just take a few minutes and talk a little bit about the vocabulary. The factors in an experiment, those are the things that you think will influence your response variable. The things that you think will influence the response variable. Levels are differences within the factors. And in our popcorn deal, the levels were the 2 different types of popcorn and the 2 different types of poppers. In medical experiments, which quite frankly a lot of what we're going to say pertains to medical experiments, because it's a common use of this. In medical experiments, levels might be different dosages of a new drug. It could be number of doses in a day, that kind of thing. Levels, differences within the factor. The treatments are combinations of factors and levels. And treatments are what are applied to, these are the things you do, applied to your units, your experimental units, right? In our case that we talked about with the popcorn, the treatments were the combination of popper and popcorn, and they were applied to the units, which were the time periods we had available. Okay? You'll notice my little blue line here, because I'm going to probably stop talking about popcorn now and more focus on experiments that take place in the medical field. I do want to just take a second and say why randomize here. And what I said earlier is we want to do that so that we can minimize confounding. And remember, confounding, we got from yesterday's lesson, is when things get so mixed up, okay, that you can't tell which factor is causing the change in your variable. We randomize to minimize confounding. And if you think about it this way, you want to know that differences in your response variable are happening either due to chance or due to your treatment. Differences in the response variable are due to chance, there's nothing you can do about that, or to your treatment. And if you see a significant difference in your response variable, that's probably not chance, it is your treatment. That's why randomizing is important, okay? The next few things that we want to talk about have to do with medical experiments, as we said, and so we're going to talk a lot about that in the next couple of days. A comparison group and a control group, those two have basically the same function in an experiment, and that is the whole compare thing. An experiment which has a comparison group, folks, is one where you take maybe and give part of your people the current drug, right? And part of your people, the experimental group, they get the new drug. Comparison group receives the standard treatment or the current treatment, while the experimental group gets the new treatment. If you think about this, if somebody was trying to design a new headache medication, the comparison group would get Tylenol, right? And the experimental group would get the new medication. Not all experiments work that way. Some, they want to make all the people who are participating believe that they're getting the same treatment. And to do that, so we're going to come down here first. To do that, folks, they will give part of their people, the control group, a placebo. And a placebo is, the not kind way to say it, it's a fake medicine. Okay, it's made to look exactly like the new med. It tastes like it, it looks like it, it smells like it, but it's not it. It's there was an episode of MASH where they called this a sugar pill. Okay, and the reason that they do this, because believe it or not, and you'll hear this in your psychology class as well, when people receive a treatment, okay, whether they're getting a fake pill or a real pill, it doesn't matter. People feel better when they are people feel better, and many times symptoms disappear when they're being treated, whether it's the real pill or the fake one. People feel better when they're being treated. It's kind of weird, really. Our mind has a lot of power that we really untapped. We don't use all of our mind. But the placebo effect, so you're doing this experiment and you've got this great new pill that's going to stop cancer, and you give it to people who desperately want to have their cancer cured, folks. They will psychologically feel better just because they're getting something, right? That's the placebo effect. But to get back where we were, a control group, they receive the placebo. And what happens with the control group is compared to what happens in the experimental group, who get the real treatment. Okay? In medical experiments, you may have heard the terms blind and double blind, and those are important, especially when you're talking about has to do with that placebo that we've just talked about. In a blind experiment, the patient doesn't know which treatment he or she is receiving. That is, they don't know whether they're getting the real pill or the fake one. That would kind of undo the whole purpose of having a fake one. The patient doesn't know which treatment they're receiving. In a double-blind study, neither the patient nor the doctor, patient and doctor, don't know which treatment is being given. There will be some lab tech that knows, okay? But the doctor doesn't, because you don't want that doctor to make his judgment based by, if he knows who's getting the real thing, he may, even unintentionally or intentionally, may slant his research to say that it's working better than it is. The patient and the doctor, both of them, don't know is being given. Okay? Blind means the patient doesn't know. Double blind means the doctor doesn't know either. And again, that's a way for the experiment to be more fair so that the results are more accurate. Experimental units, we've used that term before, but the experimental units are the objects that receive the treatments. So if you're thinking about the popcorn, the objects were the 20 time slots, because that's the thing that we randomly assigned a treatment to. If you're thinking about a medical study, the experimental units would be the patients, because they're the objects that receive the treatments. Replication just means that the treatments should be randomly assigned to many units. In conclusion, folks, we want to just go back to what we're saying in our first screen. A well-designed experiment, if we really want to say that something is making another thing happen, so we want to use an experiment to talk about causation, we have to have these three elements. We have to compare, that is, the treatment and the control groups need to be compared. Or multiple treatments, if that's the way the experiment is running. There has to be that element of comparison, otherwise there was no reason to do an experiment. Randomization needs to take effect, okay? This makes it fairer. It makes it fairer. Treatments have to be randomly assigned. And replication is important, okay? You need to do it a lot, she says with a smiley face. Another thing about replication, and maybe you've heard things like this on the news, if you're doing a fair experiment, it would make sense that someone else who does the same experiment should get a similar result to you. That also is an element of replication. Not only should you use as many subjects as you possibly can, but you also want to make sure that your result could be replicated by someone else who did the similar experiment. So that's our lesson for today. We're going to ask you to get that U-Try as soon as you can, and we'll see you in school.